So is there a supreme designer? And who is he? What is he like? Where we can get a source of information about him that's reliable. Well, the first law of thermodynamics. Dr. Patton, in a video years ago I got out, and he was fortunate and nice enough to provide detailed notes for the video. It's great. That's the way you should do it. That way you don't have to write down and go back and write down again. The first of these laws is the first law of thermodynamics. These are laws of science. Ever heard of Sir Isaac Newton? Physical laws and constants testify to a design creation. So the first of these laws we're looking at right now. The first law of thermodynamics. The first of these laws is the first law of thermodynamics, or sometimes called the law of conservation. It says that while matter or energy can sometimes be interchanged, neither can be created or destroyed. The total amount is constant. Another way of saying it is that you can't get something from nothing. I like this guy. This principle of conservation has been measured and tested and has been confirmed completely and is unquestionably a law. Just Google it. Now, long before Google, we have a science writer named Isaac Asimov, who, by the way, is an atheist. One of the more prolific science writers of their time, since our time, was writing in the Smithsonian Institution Journal, June 1970. He made this statement regarding this first law. This law is considered the most powerful and most fundamental generalization about the universe that scientists have ever been able to make. No one knows why energy is conserved. All that anyone can say is that in over a century and a quarter of careful measurements, scientists have never been able to point to a definite violation of energy conservation, either in the familiar everyday surrounding about us, or in the heavens above, or in the atoms within. And since then, still, this conclusion is true. Just Google it. Now, that's a very, very broad statement. It is the most fundamental generalization we can make about the universe according to this atheistic philosopher of science. And it pervades the universe from the atoms to the heavens. Atomic bombs, all the way up to the greatest Milky Way or the greatest star organizations, and universe as far outreach as we have been able to do with the Hubble telescope and so on. Still the same conclusion. This Isaac Asimov states is a law. We measured it. We observed it. But notice how he flies in the face of this law when he comes face to face with its implications regarding origins. This time, writing in Science Digest, he says, perhaps in an infinite sea of nothingness, globs of positive and negative energy in equal-sized pairs are constantly forming, and after passing through evolutionary changes, combining once more and vanishing. Wait a minute. I thought this was energy conservation. We have stuff coming and going. We are in one of these blobs in this period of time between nothing and wondering about it. Well, now in view of what he said, as quoted earlier, is the most fundamental generalization about the universe that scientists have ever been able to make, I think we can conclude that this second quotation is not science. In fact, it is not even good science fiction, which flies in the face of this most fundamental generalization, the first law of thermodynamics, which says that you can't get something from nothing. Something doesn't come and go, vanish and come back. Matter can be neither created nor destroyed. I find that most of the scientists that I try to talk to about origins, when it comes to talking about the origin of matter, simply sidestep, evade, or avoid the question. It came from somewhere else. And then they involve themselves in the logical fallacy of infinite regression. It came from over here. Well, where did it come from to get there? Well, maybe over here. And then, where did it come from there? Well, you see, they infinitely regress, never really getting to the point of where it all began. And when we come face to face with the laws that govern this universe, we see that there is no natural explanation for the origin of matter. The law says nothing can come from nothing. And so you must go beyond the natural explanation to what you might call supernatural. Natural law can't account for origins. Natural law says that the origin of matter won't happen naturally. And so natural laws deny the naturalistic philosopher's efforts to explain origins. And we can see the obvious conflict here. The law of conservation of energy and matter says there is a principle of conservation that matter can neither be destroyed or created nor destroyed. And yet the naturalistic philosopher tries to explain the origin of everything in conformity with natural law. But natural laws deny the possibility of the origin of the universe coming about by natural laws. On the other hand, the creation model scenario fits the existence of natural laws best, where there is a creator who operated in the beginning outside of natural law. He's not part of creation. He's uncreated. Hey, where do we go to get that information? 5-letter word, the Bible. But let's keep looking at science. The second law of thermodynamics. Second law of thermodynamics. And aided by Dr. Don Patton's wonderful video. It was so wonderful. He's a scientist, but the video's down at my level. And he gives you notes, the detailed and additional references. This guy really wants you to learn this stuff. He's not just selling videos. The second law of thermodynamics, sometimes called the principle of entropy increase, says the system runs down or wears out. And he says, and that's no surprise to us. We know that systems run down and wear out. We know that when we buy a new car, it doesn't get more powerful. We know that we ourselves run down and wear out eventually. Duh. Notice the description of it that Isaac Asimov makes in the Smithsonian Institution Journal. When he says, another way of stating the second law, then, is the universe is constantly getting more disorderly. Viewed that way, we can see the second law all about us. We have to work hard to straighten a room, but left to itself, it becomes a mess again very quickly and very easily. Even if we never enter it, it becomes dusty and musty. How difficult to maintain houses and machinery and our own bodies in perfect working order. How easy to let them deteriorate. In fact, all we have to do is nothing. And everything deteriorates, collapses, breaks down, wears out all by itself. And that is what the second law is all about. Quotations from Dr. Patton's notes that accompany his video. Excellent notes. Sir Arthur Eddington from the Physical World. If your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse and deepest humiliation. And A.B. Pippard, Cambridge University. There is no justification for the view, often glibly repeated, that the second law of thermodynamics is only statistically true, in the sense that microscopic violations repeatedly occur. Aha! But never violations of any serious magnitude. On the contrary, no evidence has ever been presented that the second law breaks down under any circumstances. So you can make this up on a microscopic level because you don't include other things that contribute to additional increases, well, that thing is still increasing, but left by itself, it decreases. Frank A. Greco, Harvard Medical School. Being a generalization of experience, the second law can only be invalidated by an actual engine. In other words, the question, can the second law of thermodynamics be circumvented, is not well worded, but can be answered only if the model incorporated every feature of the real world. All right, I got that phone call. Good doctoring help. But let's go back to Frank A. Greco. Being a generalization of experience, the second law of thermodynamics can only be invalidated by an actual engine. In other words, the question, engine? You're adding an engine? No, you can't do that because you're adding complexity and to increase and repair. That's violating the rule. Can the second law of thermodynamics be circumvented? Is not well worded, but could be answered only if the model incorporated every feature of the real world. But an answer can readily be given to the question, has the second law of thermodynamics been circumvented? Not yet. Now, this is a law, likewise, that has been observed and tested for well over a century and beyond now, and no exception has been found, as he goes on to say, this is the law. Now, how does that compare again with the two models of creation and evolution as an explanation of origins? Richard Morris, in his book, Time's Arrows, Scientific Attitudes Toward Time, a very well-known science writer, says, the second law of thermodynamics has a chameleon-like character. It can be expressed in more different ways than any of the other laws of physics. The reason that it takes many different forms is that it is the most general of all the laws that scientists have discovered. It applies to practically everything. And so, we're not then about a principle that applies only to mechanical processes, as I've heard some claim, but like the chameleon that shifts colors. This principle, likewise, applies to everything. In particular, we noticed the statement in the Dallas Morning News, 1990, regarding entropy of information. Is there a real connection between entropy in physics and the entropy of information? Well, he's affirming that there is a connection, and that it is the same thing that refers to the work of Robert W. Luckey at Bell Laboratories and John Wheeler of Princeton and the University of Texas. He says, the equations of information theory and the second law are the same, suggesting that the idea of entropy is something fundamental. Now, entropy is this tendency toward disorder, and it operates in practically every area. It is the most general of all the laws and includes information. I think the law of entropy as it relates to information is particularly relevant to the question of origins and evolution versus creation. Certainly, evolution of life and of complex organisms involves an increase of order and information. Got that? Evolution of life and of complex organisms from less complex involves an increase of order and information, right? And perhaps quantitatively, we can get a better handle on this issue if we look at it in terms of whether there has been an increase or decrease of information. We observe that there has been a general overall decrease of information, of order, of organization throughout the universe, i.e. an overall increase in entropy. And that's like an increase and decrease. And this is one of the most fundamental laws we've ever seen. And yet, in spite of that, we have statements like this from V.F. Weisskopf, head of the Department of Physics at MIT. The evolutionary history of the world being the Big Bang to the present universe is a series of gradual steps from the simple to the complicated. Wow, MIT, and you say something like that, from the unordered to the organized, from the formless gas of elementary particles to the morphic atoms and molecules, and further to the still more structured liquids and solids, and finally to the sophisticated living organisms. That's how we came. We came out of sludge. Sludge talked to itself and created man. Calling them sophisticated is an understatement. In our earlier session, we pointed out